Alright, for numbers 1, 2, and 3, we're going to use the graphs to determine if the function is even, odd, or neither. Number 1, notice how the graph reflects over the y-axis. See how it's symmetric over the y-axis? So that makes this one an even. Why? Because it's symmetric with respect, so I'll put WRT with respect to the y-axis. Number 2, notice how this one is not symmetric with respect to the y-axis, but if you were to take this half or this half and spin it on the origin, spin it 180 degrees, you would get the other half. Another way to see it is, see how this point right here is 1, -2? Well, there's a corresponding point over here, -1, +2. See how the signs changed on the points? So this one would be odd. And it's symmetric with respect to the origin. Number 3, here's a y-axis, and if you take this piece and this piece, they are identical, right? So this is the line of symmetry for this half and this half. So this is another even function. Why? Because it's symmetric with respect to the y-axis. Okay? For number 4, this is where we test algebraically to see if a function is even, odd, or neither. So for this one, replace all the x's with a -x. And if we get the original function back, then it's even. If we get the opposite of the original function back, then it's odd. If we get a combination of the two, then it's neither. So notice how I replaced every single x, so here, 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 and here with a -x. Next step is to simplify. So -x cubed is a negative, so this is -2x cubed. A -x squared is positive, but then you have a -3 in front, so that stays negative. A negative times a negative is positive, so that's +4x, and then the last number, the 4, stays +4 because there's no x to change it. Okay, so now we compare the original function, this one right here, with this one right here. Okay, now notice how positive and negative. Okay, so it looks like it might be opposite of each other. But then you go to the next term, negative, negative, they're not opposites. And the next one, negative, positive, those are opposites. And then the last one, positive, positive, they're not opposites. So this is a combination of the two, so this one is neither. Oops. It's not even, it's not odd. Okay, so for number 5 and 6, I know I told you to circle it and don't focus on it, but let me just go ahead and solve it for you so that when you do get to it, you have the solution right here. So I'll start with, I can choose any two to multiply together first, so I'll just choose these two. So this is going to be x squared minus 3x, distributing the x, and then just bring down the x plus 2. So now I'm going to do distributive property. So this one times this one, x cubed, this one times this one, 2x squared, then this one times this one, -3x squared, and this one times this one, -6x. Combine the like terms, which are these two right here. So you get x cubed minus x squared minus 6x. Okay? Okay, so let's go ahead and multiply. This time, and this is just to show you that the order in which you multiply does not matter, I'm going to start by multiplying these two. Okay, so I'll just bring down the -2x squared. And so this is x squared, and then this one with this one, 3x. This one with this one, minus x. And then this with this, minus 3. So it's negative 2x squared, x squared. Combine those, I get 2x minus 3. So now I'm going to distribute this here, here, and here. So the final answer would be negative 2x to the fourth minus 4x to the third plus 6x squared. And it's already in standard form because I have the biggest degree first, and then they go in descending order to the last term. Alright, finding the inverse. Step number 1, change the f of x to y. Then we solve for x. So to solve for x, we need to divide by 3. And once x is by itself, you switch it. So let me just put it on the left side. So x equals y minus 4 over 3. I'm going to switch the x and the y. So this is y equals x minus 4 over 3. And then change it to function notation. So f inverse of x equals x minus 4 over 3. So again, just like with number 7, we're going to replace the h of x with y. And then we're going to solve for x. So first thing is multiply by 5. So right here, 5 over 5 cancels. We're going to subtract 4. And then we're going to divide by 2. So now x is by itself. So x equals 5y minus 4 over 2. Switch the x and the y. And then change it to function notation. Now if you want, you could write it as 5 halves x minus 2. Either one is fine. So sorry, not f inverse, but h inverse. Oops. H inverse, sorry about that, of x is 5x minus 4 over 2, or 5 halves x minus 2. So either one is acceptable. Okay, so for number 9, they want you to determine whether the functions are inverses of each other. Now, it didn't say it specifically, but you need to know that when they ask you to show whether functions are inverses of each other, we do that through composition. So we're going to do first f of g of x and see what happens there. So that means we're going to take f of x, the outside function, and replace its x with g of x. I know it looks really intimidating and messy, but you'll see how quickly it simplifies. So first we're going to multiply by 3, but what happens is, notice how there's a 3 here, so the 3's cancel. So now you have 4x plus 5 minus 5 over 4. Well, 5 minus 5 is 0, and then 4 over 4 is 1, so this leaves you with x. Now that's not enough, you have to do the other direction. And so now we're going to take g of x, that's our outside function, and replace the x with f of x. So that's 3x minus 5 over 4 plus 5 all over 3. So again, when you multiply out the 4 in the parentheses, the 4 over 4 is 1. So now I have 3x minus 5 plus 5 over 3. 5 minus 5 is 0. And 3 over 3 is 1, so that gives me x. So you say, since both compositions, I'll just put comp, give us x, then they are inverses of each other. Oops, each other. something like that. Okay, for number 10 through 13 actually, you need to describe the, I know it says translation, but it should be transformation. Describe the transformation. So, for this one, it's a quadratic, and the transformation, I see an H right here, a K right here, and an A with a negative. Okay, so it's going to go left 3, reflect over x-axis because of the negative in front of the 1/2. It's going to have a vertical compression. You have to say the factor by factor of 1/2. And then it's going to go down 4. Okay, so you have to understand how A, B, H, and K affect the graph. For number 11, there's an H, a K, and this time this is B. Okay, because of its position inside, it's being squared. See how it's inside the parentheses and the square is out here? So it's considered to be like inside with the X. Because the X is being squared, so is the 1/3. Okay, so that's why it's a B. So for this one, you would say left 4 units, a horizontal, but remember the B is counterintuitive, so I see 1/3, so I think 3. So it's going to be a horizontal stretch by factor of 3, not 1/3, but 3, and then it's going to go down 2 units. Alright, number 12 only has one transformation. It's 4 times the function f of x. So this has a vertical stretch by factor of 4. Okay, now compare 13 to 12. See where the 3 is right inside the function in front of x? Compared, looking at 12, the 4 is outside of the function in front of f of x. So right here, this means it's a horizontal. Now you see a 3, but you have to think reciprocal. So horizontal compression by factor of 1/3. Okay, so for numbers 14, 15, they want us to write the equation for g of x if we started with the parent function f of x. So notice how g of x is it's the same shape, it's just lower than f of x, but it was just like you slid it down by 1 unit. See how it's 1 unit right there, 1 unit right there? So then you would write g of x is f of x minus 1, because you just went down 1 unit. For 15, notice how the vertex stayed where it is, like in the same spot, but this graph, this is the original, the taller one, but this graph got shrunk, right? It went down. So this used to be at 6, at 3.6, now it's at 3.3. This used to be at negative 3.3, this used to be at negative 3.6, and now it shrunk down to negative 3.3. So let me write down the points. So it started off at 3.6, now it went to 3.3. It started off at negative 3.6, and now it went down to negative 3.3. So notice what changed was the y. It got cut in half. So that's a vertical compression. Okay, so this would be g of x is 1/2. I put it in the front because it's a vertical compression.